already. Right. Number of ops to make elements in an array distinct. You're given an array nums. You need to ensure that the elements in the array are distinct. To achieve this, you can perform the following operations any number of times. Move 3 elements from the beginning of the array. If the array has fewer than 3 elements, remove all the remaining elements. Okay. Note that any empty array is considered distinct. So 1, 2, 3, 4, 2, 3, 3, 5, 3, 5, 7. If you remove the first 3, there's still a duplicate 3 here. And then if you remove the next 3, then you're left with 3, 5, 7, so it's 2 operations. And then if you need to remove the first 3 here, it's still 4, 4, not distinct, so you need to remove both. And there'll be an empty array, but that's distinct. Here you need to remove no operations, or you need no operations to make it distinct. Okay, so I think here, I think you should be using sets here. Sets and counters, maybe. This should definitely be linear somehow. Let's go ahead. So if we create a distinct set of values from the nums, and if the length of the set is equal to the length of the current nums, then that should mean that everything there's no duplicates. And then we probably need to know if there are duplicates. So let's go ahead and create a count. Okay. So let's say for each, say n is the length of the nums, for each index in the range of n, so the value is nums at this index, and we'll decrement the number of times. Actually, we need to worry about 3 sets of 3. Let's say index in the range of can I go 3 values, value 1, value 2, value 3? I think I might go out of bounds in that case. Okay, let's say that there's index say value 1, value 2, value 3 is nums at index plus 1 and nums at index plus 2. We do need to worry about all 3 at once, pretty much. And then I can say counts of value 1 decreases by 1, counts of value 2 decreases by 1, counts of value 3 decreases by 1. And if any of these has reached 0, then I remove it from the set of distinct. If counts at value 1 equals 0, distinct dot remove this value. Okay, so value 3 equals 0, distinct. Okay, so if they're all removed now, and if the length of the number distinct is equal to the remaining length of values, so the n minus index plus 3, n minus index minus 3. So if the index is 0 and the length is 4, then there should be 1 remaining after you remove 3 elements. So 4 minus 0 minus 3 is 1. So yeah, if the length of distinct is n minus index minus 3, then return for, or no, what's the answer? Return answer. Let's increment the answer, number operations. Actually, answer needs to start with 1, right? So this should work, I think. No, that's not right. This thing doesn't handle the case where it's like, this thing might go out of bounds. I think index should go to n minus 2. So, no, index needs to skip by 3 is the issue. So index goes to from 0 to n, going up by 3 each time. Then that still can go out of bounds because it's indexing 0 to n minus 2. So skipping 3 each time, and if n is 3, then n minus 2 is 1. So 0 to 1 is just 0 in terms of the bounding. So that seems fine. So it doesn't go out of bounds now, but it doesn't really handle the case where you have n is 2 originally. If n is 2 originally, then n minus 2 is 0. And it doesn't actually do a loop in that case. So how to handle like the remaining 2 or remaining last element. If it's remaining 1 element, then it has to be distinct. If it's remaining 2 elements, then if it's remaining 2 elements, then it depends on whether or not you need to do one last operation to remove that up. So if it's reached the end here, that means there's only one more element or 2 more elements in the array. If this point either dealing with 1 final element or 2 ending elements. So we'll say if it's 1 final element, then if it's 1 final element, no, that's not true, right? So you removed, no, it is true. You've removed everything up to this final element. No, so if it's up to this point and there's still If there's still elements, then you need to remove it one more time. So return the answer at that point. I guess you've already incremented here. Okay. Alright, so it worked for these two. So the check here occurred assuming that you already had an answer removal. So I just need to do another check here if the length are distinct. Is equal to n at this point, return 0. So because it could be removing it twice, I can use discard, otherwise it's going to give an error saying that I'm trying to remove an element that is not there in the set. I thought it was pretty fast, but not fast enough. How do we make this faster? Once minus equals value. So I'm going through 3 values at a time. Value 1, value 2, value 3. I decreased the counts for each of those values. If the counts is now 0, then I discard the value from the set. I wonder, I could go and make the set of non-distincts. Set of non-distinct values. I'm going over the counts and creating a set where the counts is greater than 0 or greater than 1, then it's a non-distinct set. And then I could track those. Does it seem like it'd be faster? So if you have operation 1, 2, 3, subtract the counts for each of those. Yeah, I mean, don't really care about subtracting counts of things that you only have one of. It's only about the things that you have multiple of. You're just trying to get rid of the ones that you have multiple of. Worth it? Alright, let's consider that possibility here. So for every value and frequency and counts, let's create a multi-set of nums. set of numbers that are multiple. If the frequency every value frequency in counts dot items pick. Frequency is greater than 1. Multi dot add this value. And let's just see if this is working correctly. Okay, so there's 2 and 3 is multiple here. 4 is multiple, and nothing's multiple. Alright, let's try just working with that. For every index, so let's say answer is 0. Actually, let's say while multi is answer is 0. So while the length of multi is greater than 0, we'll do index while length of multi is greater than 0. Sure, we'll do value 1, value 2, value 3 is, and then set those indices. It's kind of like you're creating a loop where you have 2 conditions in your loop that you are kind of considering. One is the index, and then the other one is this other condition about multi. In case index is going to increase by 3. And then you have your decrementing counts. So if counts value 1 decrements counts. Actually, if value 1 is a multi-value, if value 1 is multi, and okay, let's say value 1, the count of value 1 is decremented, now equal to 1, and it's not longer multiple, so multi dot remove value 1. And I'll do that for value 2 and value 3. Value 2 multi decrement is now equal to 1, this moved. Value 3 and then so after all this, if okay, yeah. So then you just look at how many things are left in multi. If the length of multi is greater than 0, and maybe index plus 3 is less than n, index plus 2 is less than n. So index is 0 plus 3, 0 is 0, 1, 2, index plus 2 is less than n, in order to make it all in balance. Okay. And here the answer should be incremented inside the loop. And if so, finally, if you're outside the loop and you do not have multi, if length of multi is still greater than 0, then you need to do it one more time. Return answer plus 1. Else return answer. Okay, I think this might work. I don't think this is any faster. Oh, it is faster. Oh, users. Okay, I guess there's probably other solutions that are equally as fast, but this is apparently fast enough. So I didn't use distinct, I just used multi. And then I created the multi-set. And then I think I can make this answers. Return answer plus 1 if length of multi is greater than 0. Else return answer. Make this more appealing looking, I guess. Maybe move this down here. You create accounts, you create a multi-set, yeah, create the multi-set. Minus the length of numbers. Oh, and that looks pretty tidy. And just double check everything. Okay. Eight milliseconds, 0 milliseconds. I'm pretty sure there's no way that this thing is actually should have gone slower. Okay, anyways. It got 0 at one point. I don't think it should have got slower. Maybe the other one was just equally as fast, but it's just a slow runtime for that runtime. Okay, anyways, summary here. So in any solution, you want to keep a track of counts of value frequency, or get value frequency using counter, and either track a set of distinct values using set on the values and set on the nums, or create set of non-distinct values or multiple values by from values that have frequency greater than 1 in counts. Then iterate over every 3 values in nums, changing frequency appropriately and adjusting either distinct or multiple sets until the remaining values are identified as distinct. And this could be like the remaining number of elements is the same as the size of the set, or size of this distinct set, or there's no more elements in the multiple set. Let's see this open. For passing through to create the counts and adjusting the sets. And that's basically, let's see, this is also open. OV. No. It's open for the size of the counts. Counts